Hi, my name is Azize Engin, and for pre-calculus, this is my problem on projectile motion. A ball is on a platform that is 80 feet off the ground. It is launched directly upward with a velocity of 64 feet per second. Given this information, calculate the ball's maximum height and the time at which it attains this height. The first way to solve this equation is through graphing. We'll be using the equation ST, later on referred to as Y, equals negative g t squared plus v0t plus h0. v0 will be representing the initial velocity and h0 will be representing the initial height. This value will be the maximum velocity and t will be the time at which that height is reached. Given the numbers that are provided in the problem, you can then plug them into the equation. We're using 16, which is derived from the force of gravity, and that we're using this because the units are in feet. If it were in meters, we'd be using the number 4.9. From there on, you have y equals negative 16t squared plus 64, which is the initial velocity, plus 64t plus 80 h0, or plus 80, which is the initial height. After you plug in the equation, after you write out the equation, you can then plug it in to the y equals feature on your calculator. After you do that and type it into y1, you can then hit the graph button to get a graph that looks like this. In order to find the number graphically, you can merely go to second, trace, which will bring you to this calculate page. Then click 4 so you can calculate the maximum. Keep on pressing the left button until the little star that appears on your calculator is in your view on the left side. Right now, that's it. Once you have it, press enter. Then move it up until the star comes down on the right side of the graph. Here it is. Press enter again, and now you have two located spots on either side of the graph. Then press enter again, and your calculator will generate the two numbers that come up for the maximum. These plot points are 2 and 144. X here shows that it equals 2.000001, so we're just going to round that off to 2. Solving this graphically, we learned that after 2 seconds, the ball will reach its maximum height of 144 feet. Solve this is by using a data table. Again, we'll be using the equation y equals negative 16t squared plus 64t plus 80. Since I first solved it graphically and know that the maximum height occurs at 2 seconds, I've chosen numbers that all surround that number. I first chose 1.50, 1.99, 2.00, and 2.10. Starting with the first value, you can plug it into the equation. So you get negative 16 times 1.5 squared plus 64 times 1.5 plus 80. This gives you an answer of 140. This represents the height at which the ball reaches after 1.5 seconds. Utilizing this method again for 1.9, you get 143.9984. Using it for 2.0, you get 144, and then using it finally for the quantity 2.1, you get the height of 143.84. Out of these numbers, I know that using 2.00 seconds gives me the highest point, showing that that is the maximum height, further verifying that after 2 seconds, the ball will reach its maximum height of 144 feet. The final way to solve this problem is algebraically. In the last 2 times, I learned that the plot points that will give me the maximum height are 2 and 144. If you want to verify this answer, you can either take 2 or 144 and plug it back into the equation. First, I'll be taking 2. Using the equation, again, y equals negative 16t squared plus 64t plus 80. I'll get the equation negative 16 2 squared plus 64 times 2 plus 80. This gives me an answer of 144, further verifying that this is correct. If you want to determine the time based on the maximum height, you can then plug in 144 for the y value. Using this, you can then subtract 144 from 80 on the other side, so you get a 0 on the left side of the equation. This gives you the equation negative 16t squared plus 64t minus 64 yields 0. Factoring a negative 16 out of this equation, you get 0 equals negative 16 times the quantity t squared minus 4t plus 4. These signs are switching because you're factoring out a negative number. After getting to this step, you can then further factor this by making it 0 equals negative 16 t minus 2, that quantity, squared. Divide either sides by negative 16, yielding 0 equals the quantity t minus 2 squared. Once you are at this step, you can merely use the equation t minus 2 equals 0 to solve for t. After you do that, you'll realize that t equals 2, showing you that after 2 seconds, the ball will reach its maximum height of 144 feet. Thank you for watching.